Okay, so I started working out this problem where we have to use 498 and 499 to prove that reflectance plus transmittance equals 1 for both components. And I used equation 462 from the textbook, where it says the reflectance is equal to the amplitude of the reflection coefficient squared. And I also know from equation 443, this red one here is 443, that R is tan, but it's squared, so I squared it. So this is 443. And then so tan squared is sine squared over cosine squared. Which I could rewrite as and then the denominator is the same, so instead of dividing by tan squared I multiplied by the reciprocal, and then I'm gonna add it. So now notice that this and this, they both have the same denominator here, so I just added them, and now we know that sine 2 theta I is 2 sine theta I cosine theta I, and so is sine 2 theta t, so 2 times 2 is 4, and we get this. And now let's see, we're gonna have to FOIL sine squared theta I theta t, so what's sine? So let me take these squares on top of the whole thing, probably better. Okay, let's FOIL. So sine theta I, so that's sine, we start at the beginning, I'm gonna need the space, so this is equal to sine, so sine theta I, trig identities, cosine theta t minus cosine theta I sine theta t times the trig identity for the second one is cosine theta I cosine theta t minus sine theta I sine theta t, and this whole thing is squared, and then here we have 4 sine theta I theta t okay. Okay, since the trig is getting a little long here, let me just do the numerator separately, and I'll come back to the denominator. Might just be easier. So let me take this guy to the right a little bit. Yeah, I do. Uh, 2040, but I'm still working on the trig. 2040. Okay, so let's see here. So this here, this whole thing is the numerator plus 4. So this is the numerator. Okay, plus 4 sine theta I cosine theta I sine theta t cosine theta t. Okay, and there's a square on this whole thing. Okay, so let's multiply this through. So this is gonna be sine theta I cosine theta I cosine squared theta t minus sine squared theta I cosine theta t sine theta t minus cosine squared theta I sine, so I'm foiling these two expressions here, sine theta t cosine theta t plus here they're all different, so cosine theta I sine theta I sine theta t sine theta t, so that's sine squared theta t, and this whole thing is squared, and I'm gonna add it to the last term, which is 4 sine theta I cosine theta I sine theta t cosine theta t. Okay, so this whole thing is the numerator n. Okay, let's see how we could go further here. Well, we can see that there is a cosine squared here and a sine squared here, and these two are the same thing. So if we factor this out, we will get cosine squared theta t plus sine squared theta t, which is 1. Okay, this is a great simplification. And likewise, we have here sine squared theta I cosine squared theta I, and those two are the same, so I'm going to factor them out with a minus cosine theta t sine theta t into sine squared theta I plus cosine squared theta I, and this is again a 1. Okay, huge relief here. Squared plus the 4, let's continue on red, plus 4 plus this guy here sine theta I cosine theta I sine theta t cosine theta t. Okay, so this whole thing is the numerator. Okay, let's see. So now it's easy to square that. So now we're gonna continue. So this is gonna be sine theta I cosine theta I squared minus 2 sine theta I cosine theta I cosine theta t sine theta t. So 2 times the first times the second plus the second squared cosine theta t sine theta t squared, and notice I have here plus 4 sine theta I, the last term, cosine theta I cosine theta t sine theta t, which is the same. Okay, nice. So this will work out to, if I add these, I will get the middle term to be 2 sine theta I cosine theta I cosine theta t sine theta t, and the end terms are the same. The end terms are the same. So this factors to the same exact thing it was before, except instead of the minus 2 we have plus 2. So I could factor this back into sine theta I cosine theta I plus cosine theta t sine theta t all squared. Okay, so this is the numerator. This is, I think, as concise as we can get. Okay, let's see what the denominator has. Cosine squared, sine squared. Okay, so the denominator is cosine squared theta t minus theta I minus theta t, theta I minus theta t times sine squared theta I plus theta t. Okay, so we're gonna try to prove that this is the same, and I could take this squared and make the whole thing squared. So the denominator becomes, so cosine, the sum of the cosine of the angle difference is cosine the first cosine the second plus sine the first sine the second times sine, the sum is sine the first cosine the second plus cosine the first sine the second. Okay, Ben, this is working out, almost there. Okay, and this whole thing is squared. And so let's see. Okay, let's FOIL it. I think we did something very similar up there, and so we get cosine theta I, sine theta I, cosine squared theta t, plus cosine squared theta I. So I'm distributing these two inside terms, cosine theta t, sine theta t, plus sine squared theta I, sine theta t, cosine theta t, plus, let's try to squeeze the last one here, sine theta, yeah, sine squared theta t, sine theta I, cosine theta I. Okay, and this whole thing here is squared. Okay, so let's see, we have cosine squared here, theta t, and sine squared theta t, and those two are the same. So just like I did above, if I factor out sine theta I, cosine theta I will get cosine squared theta t plus sine squared theta t, which will get me 1. So let me just summarize a little bit here so I don't have to write the whole thing. So this will just be sine theta I, cosine theta I, and then the same exact argument applies on these two. This sine, cosine squared theta I, sine squared theta I, and these two are the same. So if I factor out sine theta t, sine cosine theta t, I will get cosine squared theta I plus sine squared theta I, which go to 0, and I will be left with cosine theta t, sine theta t. And this whole thing is squared. And this is exactly what we got in the numerator. Sine theta I, cosine theta I, cosine theta t, sine theta t squared. Yep. So this is the same exact thing as this. So the numerator over the denominator equals 1. So we would have proven that R parallel plus T parallel equals 1. So this is the first part. Now the second part, we have to prove that the perpendicular components add to 1. So let's see. So we have, so we're done with the first part of the question. So this was 1 and we proved it. So let's go to 2 and prove it. So for number 2, we know that R perpendicular equals R perpendicular squared. This is equation 461. And we also know that R perpendicular is minus sine theta I minus theta t over sine theta I plus theta t. This is equation 442. Okay, so then if that's the case, let's use that. So that means our perpendicular has to square that, will be sine squared theta I minus theta t over sine squared theta I plus theta t. And now these two have the same denominator, so I could just add them up. So I'll use t perpendicular from above, so that means t perpendicular plus r perpendicular. Since they have the same denominator, I can just lay them over theta I plus theta t, and on top that was sine 2 theta I sine 2 theta t plus sine squared theta I minus theta t. Okay, so let's see. Let's take the numerator and work it out separately, since the trig may belong here. So I will take this guy here, call it the numerator n. So n equal to sine 2 theta I sine 2 theta t plus sine squared theta I minus theta t. Okay, so I will use the trig identity. Sine 2 theta I is 2 sine theta I cosine theta I, and same thing for sine 2 theta t, 2 sine theta t cosine theta t plus, now I could put this squared over the whole thing and open up the angle difference. So sine theta I minus theta t will be sine the first cosine the second minus cosine the first sine the second, and this whole thing here is squared. Okay, so let's open up the square. So the numerator will equal, let's leave these to the same, 2 times 2 is 4, so we have sine theta I cosine theta I sine theta t cosine theta t plus okay, so let's FOIL this up. So we will get sine squared theta I cosine squared theta t minus or plus cosine squared, so square the second, theta I sine squared theta t minus 2 times the first times the second, so minus 2 sine theta I cosine theta I sine theta t cosine theta t, and you can see that these two are the same, so we can add them up and we will get the numerator to be sine squared theta I. That's the second term as is. These two terms will add up to two of them. 2 sine theta I cosine theta I sine theta t cosine theta t plus the last term as is. And notice that I can factor this back to the same exact factoring it had here, except a plus instead of a minus, because now I have plus 2. So then the numerator turns out to be sine theta I cosine theta t plus cosine theta I sine theta t all squared. And if we look at the denominator, we have right, so what is this? Let me go a step further. So this is sine cosine plus cosine sine. This is using the sum angle identity. This is sine the first plus the second, so sine theta I plus theta t all squared. And the denominator is the same exact thing. So that means therefore t perpendicular plus r perpendicular now is, the numerator turned out to be sine theta I plus theta t sine squared, and the denominator is the same exact thing, sine squared theta I plus theta t as is, so hence they add up to 1. This concludes the proof to this question.